Hello students, here we are given that a factory makes tennis rackets and cricket bats. A tennis racket takes 1.5 hours of machine time and 3 hours of craftsman time. And the same is given about cricket bat also, the machine time and the craftsman time. So before reading the question itself, we can have a table kind of thing so that it becomes easy to retain the data. We don't have to read the question again and again. Craftsman time. So since everything is in hours, let's say the unit is in hours. So the tennis racket, this takes 1.5 hours of machine time, 3 hours of craftsman time. Cricket bat takes 3 hours of machine time and 1 hour of craftsman time. So now we say in a day the factory has the availability of not more than 42 hours of machine time and 24 hours of craftsman time. So first of all, let us say that let X be the number of tennis rackets being made by the factory, and for cricket we can say let the number be equal to 1. Cricket bat. Therefore, since they have given us a limit 42 hours of machine time, so 1.5 into X would have been for tennis and 3Y would have been for the cricket bats, and this has to be less than 42, and 24 hours of craftsman time. So 3X plus Y less than 24. So these are the two constraints. Then they say that if the profit on a racket and on a bat are rupees 20 and rupees 10 respectively, find the number of tennis rackets and cricket bats that the factory must manufacture to earn maximum profit. Make an L.P.P and solve graphically. So these are the two equations. Also we know that these X and Y should be greater than or equal to 0. Also, what are we supposed to maximize? We are supposed to maximize the profit. So let's say profit, that is going to be rupees 20 for each tennis racket and 10 for each cricket racket. We have to maximize this. Maximize Z equal to 20x plus 10y. Let's call this as first equation for our L.P.P. Second constraint, third constraint and fourth. Represent these constraints as the graph now. So second and third are linear equations, and the fourth one shows that we have to be concerned only in the first quadrant. We draw these lines, 3x plus y equal to 24 and 1.5x plus 3y equal to 42. Since we were concerned about less, we shade the region that is near to origin, and the intersection, as you can see, is OABC. This is called the feasible region. So the corner points are A, which is 8, 0, which can be easily found out. C, which is 0, 14, this also can be easily found out. O, of course, is 0, 0, and B. For B, we will have to solve the two equations, which are 3x plus y equal to 24 and 1.5x, or let's say 3 by 2x plus 3y equal to 42. So we can multiply this first one by 3, subtract these and get the value of x and y. So this comes out to be equal to 4, 12. So now we find out the value of z, which was the value of the profit, 20x plus 10y at all of these points. So here it would be 20 into 8, 160 plus 10 into 0, 20 into 4, 80 plus 120, so 200, 140 and 0. So we see that this is the maximum. Therefore, we'll say that the maximum value of z is equals to 200 at x is equals to 4 and y is equals to 12. Therefore, the factory should manufacture 4 tennis rackets, 12 cricket bats to earn maximum profit of rupees 200. Earned by making, we should always give a language which is relevant to the question. 4 tennis rackets and 12 cricket bats. So this is the solution to our problem.